All right, now here's a good look at Newton's law of cooling. I showed you guys this the other day on how that works. So let's go ahead and take a look. Newton's law of cooling is here. You can see what U of T stands for. T is the surrounding temperature. U sub 0 is the initial temperature of the object. K is rate and T is time. Let's take a look at the problem that we have here. Okay. So we're going to heat up this object to 100 degrees. After 5 minutes, the object is 80 degrees. The room the object is in is 30 degrees. Really cold, freezer, I guess. When will the object be 50 degrees? Okay, now what we're going to do is we're going to take this part right here in the beginning, and we'll use all of this to first figure out what K is. Let's plug in everything that they tell us into the formula. Okay? An object is heated to 100 degrees. What that is going to be, that 100 degrees right there, stands for the initial temperature of the object, U sub 0. Okay? So that's going to go in for that. Okay? Next, after 5 minutes, so that'll go in for this T right here, the object will be 80 degrees. That's the temperature at a certain time, and that will go in for U sub T. Okay? And then finally, okay, we have one more number we have. The room, the temperature the object is in is 30 degrees. That 30 degrees will go in for this T and this T. That's what that capital T stands for, the temperature of the surrounding area. So you can see that we're going to be able to solve for K because we'll be able to plug in for everything. So let's go ahead and find K first. So let's plug in our numbers. Okay, U sub T we said was 80 degrees. Capital T is the temperature of the surrounding area, which is 30, plus our initial temperature, that's 100, minus temperature of the surrounding area again, 30, E to the 5, that's our time, K. Let's go ahead and solve for K. Now what are we going to do first? I think we should figure out what that parentheses is first. That's going to be 70. Subtract 30 from both sides. Divide by 70. Okay. ln on both sides. So that'd be the ln of 50 over 70 equals 5K. So it looks like our rate is going to be that for K, ln of 50 over 70 all over 5. Now hopefully this is decreasing in temperature, right? We should get a negative K. Let's go to our calculator and do exactly that. So we'll go the ln of 50 over 70, and we'll take that quantity and divide that by 5. Okay, there's our rate. Ooh, it's negative. So it's losing 6.7% every minute. All right, you know where we're going from here. We're going to store this in K, right? Okay. So we've got that. Let me put that in the document, what we've done. Okay. So we have our K number. All right. Ooh. Way down here. Okay. So we've got K. Now let's go ahead and answer the question. When will the object be 50 degrees? When will the object be 50 degrees? Okay. Now, what are we going to do? When? That sounds like we're going to need a time, right? So when is it going to be 50 degrees? It's going to be 50 degrees at the end, right? So we want to put 50 in for u of t. All right, our 30 is going to be the same here, plus we still have heated it to 100. Our room is still 30 degrees, e to the kt. Now k, we know what that is, and we're going to solve for t. What do you guys think is coming up first? All right, yep, we're going to go ahead and figure out the parentheses. Okay, now we're going to solve for t. That's what we're going to do. Now we're going to use our great algebra skills to do this. So Aaron, what do you think we're going to do first right now? That's right, we're going to subtract 30. I know you would get that right. And then divide by 70. Time for ln. ln both sides, really. And then divide by k. And then we'll go to our calculator. This should be our answer. Okay, so let's start over again. ln over 70, and then we will divide this by k. All right, there we go. And if we round this to the nearest minute, that would be 18.61 minutes. Let's go minutes and seconds. What would that be? So I'll subtract off the 18 off of there. Times that by 60. All right. So if I round in the nearest second, 18 minutes and 37 seconds. I'll go ahead and put that in my document, how we did that. Okay. Oh, not that. Let's see if I can do, I think I just messed that up a little bit. There we go. Okay. So there's our answer for that, and we'll do that. 18 minutes, 36 seconds. Now guys, I'll show you this last part. Here's where I want your homework to be. Let's not do Math Excel. All right, let's try these 3 problems for homework tonight, and I will see you next time. Thanks for listening.